Chapter 11, Section 3 is about taking those radical expressions we've been simplifying and now turning them into equations that we can solve. So by the end of this lesson, you should be able to solve equations with radicals and then identify something called extraneous solutions. And we'll talk more about what those are when we get to that. So a radical equation is an equation that has a variable underneath the radical, or in the radicand. You can also often solve a radical equation by getting the radical by itself on one side, and then you square both sides. So the key here is you need to get the radical by itself before you can square. Remember that squares and square roots cross each other off, so that's how we're going to undo things. Just like if we take a look at A, hopefully everybody remembers how to get something like this by itself. All we would have to do is subtract 7 from both sides because addition and subtraction cross each other off. So we would end up with the square root of x equals 12 minus 7, which is 5. And then to undo this, what we need to do is square both sides. Whatever you do to one side, you got to do to the other. So the square and square root cross each other off, and our answer is 25. And an enormous part of this section is that you have to check your answer. It is not optional, and we'll see why when we get to a couple of the harder problems. So plug this back in. If I take the square root of 25 and add 7, it should end up equaling 12. Square root of 25 is 5, plus 7 definitely gives me 12, so I know that's the right answer. Let's skip B and just do C. Now this one's a little different because the c minus 2, all of this is underneath the square root. So right now the square root is by itself. Where here I had to subtract 7 first because the only thing underneath the square root was the x. So I can immediately jump to squaring both sides. The square and square root cross each other off, so I get c minus 2 on this side equals 6 squared, which is 36. And now we get to add 2 to both sides, so c has to be 38. And then make sure you check this. So plug it into the original equation. I want to take the square root of 38 minus 2 and see if that equals 6. So we end up with the square root of 6 equals 6, which we know is true. So they're not always going to be that easy. Sometimes you're going to get ones that have square roots on both sides like this. With these ones, since everything that we have is underneath the square root, all we have to do is square both sides. Squares and square roots cross each other off, so you get 3t plus 4 is the same thing as 5t minus 6. And now this is an equation that we learned how to solve way back in chapter 3. So you get 4 equals 2t minus 6. Add 6 to both sides. And divide everything by 2. So we get t equals 5. Now just like the last one, we have to make sure that this works. So plug it in. 3 times 5 plus 4. Take the square root. I want to know if that's equal to 5 times 5 minus 6. So 3 times 5 is 15, plus 4 would give me 19. And then 5 times 5 is 25. If I take away 6, I also get 19. So the square root of 19 equals the square root of 19. I know that I have the correct answer. So this is where those extraneous solutions come in. The word extra is literally hidden in extraneous, and that's what it means. It's a solution that we get when we solve, but that doesn't work in the original equation. When you solve an equation by squaring each side, you create a brand new equation. This new equation may have solutions that do not solve the original equation. So let's say we start with x equals 2. I'm telling you what x equals. If I square both sides of this, I get a new equation, x squared equals 4. Now if I take the square root of x squared equals 4, I technically end up with 2 solutions here. And that's because there are 2 numbers that work in that equation. I can plug in 2, and if I square it, I get 4. And I can also plug in negative 2, and if I square it, I get 4. So because of that, there's two equations, or two numbers that work in this equation, but these don't work in this equation. It's only one of them. So sometimes when we square things, we create an extra solution that doesn't work. So that's why you have to check your solutions to make sure if you have an extraneous one. So in Algebra 2, you'll learn how to solve problems like this. And when you solve it, you're going to end up with two solutions. You're going to get x equals 3 and x equals -2. Now both of these solutions could work, or maybe just one of them works, or maybe neither of them work. Maybe when you solved this, you ended up with a new equation that got two solutions, but only one fit in the original equation. So what we have to do is we have to plug this in and see which ones work. So let's try x plus 3, or x equals 3. So I'm going to replace everywhere I see x with 3 and see if I get something that's true. So 3 equals the square root of 3 plus 6, which is the square root of 9, and we get 3 equals 3. This is definitely true, so 3 is a solution. But now if we try plugging in x equals -2, something a little different is going to happen. Everywhere that we substitute this in, we get something like this. And the square root of 4 is +2, which is really close to -2, but it doesn't work. So this solution right here is extraneous, or extra. Because you square it, you could end up with 4. Like if you do -2 squared, you get 4. And that's where this comes from. But when you take the square root of 4, you don't get -2. So always double check your solutions. Alright, so let's try solving one like this. Remember, our goal is to get the square root alone. So let's subtract 8 from both sides. We get negative square root of 2n equals 12. And then this negative needs to go away. Remember, it's kind of like a -1 being there. So let's divide both sides by that. So we get the square root of 2n equals -12. Now when we go and square both sides, square and square root cross each other off. And -12 times -12 is 144. Now if we divide by 2, we end up with n is 72. So let's go back and check this. Let's see if it works. So I have 8 minus the square root of 2 times 72. Now I want to know if that equals 20. So 8 minus the square root of 144. So 8 minus 12. And 8 minus 12 is not 20. It's -4. So this solution doesn't work. And since that's the only solution we had, this equation has no solutions. And once you do a couple problems like this, you'll notice where we went wrong. If you go back and look here at this negative blue part before we squared both sides, I had the square root of something equaling a negative number. Now the negative number disappears when you square it, but we still had something once you take the square root equal a negative number, and that can't happen. No square root equals a negative number. Ever. And that's why when we plug this in, it gives us something that would be 20 if we could add it, if you could subtract the negative that you had in here. But since you can't, this problem has no solutions. So I left you 2 to try. Solve this one with radicals. Make sure you check your solution. And then can you identify extraneous solutions? And this one kind of asks you to think a little deeper than what we actually did with the problem. So if you have any questions, write them down and we can go over them in class on Monday. Enjoy your night.